Okay, in this video, we're going to use the chain rule to try to determine this derivative in example 1. So let's first take a look at the setup, right? So the setup is that we're starting with a function f of two variables, x and y, and then here, so it's not specifically stated, but you can take a look at the expressions for x and y and notice that x is a function of only one variable, t, and y also is only a function of one variable, t, right? So again, it's not specifically written out here, but we can think of x as just having a single variable t and y as having just a single variable t. So the setup for this example here is exactly this setup here, right? So f of xy, and then x of t, and then y of t. And so the chain rule for this specific setup is exactly this expression here. Okay, so let's first set up everything we need for the chain rule, right? So here, in the chain rule, as part of the chain rule formula, we have both partial derivatives for f, and also we need to differentiate x with respect to t, and also differentiate y with respect to t. So basically, from these three equations here, we have to determine all possible derivatives. So let's do that. So first, the partial of f with respect to x. So I'm thinking of y as a constant. So this whole term, e to the y, is considered a constant coefficient, so the derivative doesn't affect that. And then now I differentiate x squared, which is just 2x. So let's put the 2x in front so that I can write this as 2x e to the y. Okay, so now what about the partial with respect to y? So the partial with respect to y, so now I'm thinking of x as constant, so x squared is a constant coefficient, so the derivative doesn't affect that. And then the derivative of the exponential is exactly the same exponential, so the partial with respect to y is exactly the same. Okay, so now I also need to differentiate x and y, so let me just write it as x prime. So the derivative of x with respect to t is just 2t, and then the derivative of y with respect to t, so the derivative of sine is cosine. Okay, so these are all the different derivatives involving these three functions. Okay, so now we put it together according to the chain rule. Okay, so first I use the subscript notation here and the prime notation here instead of this notation. So let me rewrite the chain rule formula according to the subscript notation, right? So it's the partial of f with respect to x times the derivative of x with respect to t plus the partial of f with respect to y times the derivative of y with respect to t. Okay, so this is exactly the chain rule formula, the way I've written it here, right? So let me just write it down again here, right? So dz dt is going to be the partial of f with respect to x times the derivative of x with respect to t plus the partial of f with respect to y times the derivative of y with respect to t. Okay, so now I just need to plug these different things into the chain rule formula. So let me start over here to give myself a little bit of space. So the partial of f with respect to x is exactly this thing here. So 2x e to the y, and then times x prime, which is 2t, plus the partial of f with respect to y, which is this expression here. So x squared e to the y, and then times y prime, which is cosine of t. Okay, so that's what we get. And then now notice that this expression here contains three different variables, x, y, and t, whereas ultimately we want everything in terms of only t, right? So so what do I want answer in terms of only t. And so how do I do that? So I need to take the original expressions for x and plug it into the answer, right? So we plug x equals t squared minus 1 and y equals sine t back into the answer. Okay, so we let's do that. All right, so plugging this just into x and this into y. So what do we get? 2 times x, which is t squared minus 1, e to the y, which is sine t, times 2t, plus x squared, so you have t squared minus 1, squared e to the y, so I get a sine t there, and that thing times cosine t. Okay, so that's what we get. And then finally, it's not completely necessary because sometimes these expressions can be somewhat complicated, but we can simplify a little bit. So let's multiply this thing here. So 2 times 2 is 4, and then multiplying by t, you get t cubed minus t, e to the sine t, and then plus. So let's put the cosine in between here. This thing let's leave alone. Okay, so that's what we get as the derivative after applying the chain rule. Okay, so one thing to be aware of is that there's an alternative way to do this. So what you do is you take x and y and just plug it into the original function first. Right, so basically you write f of x of t, comma y of t. So do the substitution first. And so if we do that here, what does it look like? So x was t squared minus 1 squared, right? So that's this x squared, and then e to the y. So e to the sine t like this. So you get this expression, and then basically the final answer should be the same as if you take this expression and do the derivative as you did in Calc 1. So the answer should be the same. So I mean, you can try to work it out yourself and compare the thing, but one warning is that it's not so simple, right? Because you have the chain rule and the product rule going on here, right? So here there's a multiplication here, so that there's going to be a product rule. This requires a chain rule. This also requires a chain rule, and so on and so forth. So again, you can try to take the derivative of this following all the stuff you learned in Calc 1. You should get the same expression as we did here.